Topic 3, Day 2, Trigonometric ratios. So trigonometric ratios are useful when you're given a right triangle and you're looking for a side, given you have a side length and you already have an angle measure, or you're solving for an angle given you already have two side lengths. In order to use trig ratios, we need to first be able to correctly label our opposite, adjacent, and hypotenuse sides and theta. Theta is a variable that we use to denote the angle that we're interested in. All right. Usually, if the angle measure is given, excluding the right angle, that angle is theta. All right. Or if there's an angle that we're solving for, that angle is theta. From the point of view of theta, the opposite side is the furthest away from the angle. The hypotenuse is always your longest side, right? And adjacent is next to theta. So here in this diagram, theta is already labeled for us, right? It's the angle that we're interested in. Either it's given to us or we're solving for it. From there, the side that's furthest away from theta is our opposite, right? We already know how to find the hypotenuse. We always look for your right angle, and it's opposite your right angle, and then adjacent is next to theta, okay? Now, we have here that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So a mnemonic device that you can use to memorize is SOHCAHTOA. All right, so sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent equals opposite over adjacent. Okay. Now our angle of elevation and depression is always calculated from the horizontal. All right, so if you have a person, there's an airplane in the sky, the angle of elevation is the angle that's created from the horizontal here, and then the angle that's created by looking towards the plane. That is your angle of elevation. Similarly, if we're looking from the point of view of the plane, the angle of depression is from the horizontal to where the person's eyesight is, right? So from the horizontal and then moving downwards, all right, is the angle of depression. So if we have story problems, a lot of times I'll use that verbiage. Let's look at teacher example number 1. Find the value of tangent f rounded to the nearest hundredth. Okay, so here it's not asking us what is the side length. We already know the value of all of the side lengths. It's asking for the value of a ratio. And we know that tangent is equal to opposite over adjacent. So pretty much what it's asking us to do is figure out from angle F's point of view, what is the ratio created when we do opposite over adjacent? So opposite is 20 and adjacent is the square root of 84. It says to round to the nearest hundredth, so I would just plug that into the calculator. And when we do that, we get 2.18. A couple of things to be careful of. Number 1, make sure that we're rounding correctly. And then number 2, make sure that we're in degrees if we need to be in degrees, okay? We haven't talked about what radians are yet, but we're going to eventually. And then later on, you might have to do some trigonometric ratios in radians. However, for these problems, since we haven't talked about radians yet, should always be in degrees. So on your calculator, you can click mode and then go down a couple of arrows and make sure we're in degrees. Okay. And we know that we're in degrees because we have that little degree symbol there. Teacher example number 2 says to solve for x and round to 3 significant figures. Now we are solving for a side length. Okay, so first, we're given this 54 degrees. So that is our theta. The 2.3 is opposite our right angle. So that is our hypotenuse. X is opposite of theta. and then adjacent is next to theta, and it's not the hypotenuse. And what we'll find is we're solving for x, we're given the hypotenuse. So we need to pick a trigonometric ratio that uses opposite and hypotenuse. So if we do TOA, which one has opposite and hypotenuse is going to be sine. So sine of theta equals opposite over hypotenuse. And we can start filling that in. We know that theta is 54, opposite is x, and hypotenuse is 2.3. We want to get x by itself. Right now it's being divided. The inverse of division is multiplication. Oops. It should be 2.3. So we're going to multiply both sides by 2.3. And when we put that into the calculator, 2.3 times sine of 54, you'll get that x is equal to 1.86. And that is 3 significant figures. So that's my final answer. I want to take a second, though, to think about, does this answer make sense? Right? If I think about this as 1.86 and my hypotenuse is 2.3, the hypotenuse has to be my longest side. So since my x value is less than 2.3, it's kind of a good hint that my answer makes sense. Go ahead and try student example number 2 on your own. Now our third teacher example is a little bit different because now we're solving for an angle, right? We're solving for this angle x, and we're given 2 side lengths. So we know that the angle that we're solving for is our theta. We know that our hypotenuse is opposite our right angle. The 9.3 is our opposite, and the 7.5 is our adjacent. From there, we still need to decide which ratio to use. So we're given the opposite, we're given the adjacent. I don't know anything about the hypotenuse, so we should pick a ratio that has opposite, that has adjacent. So TOA, opposite over adjacent is going to be our tangent. So tangent of theta equals opposite over adjacent. Now we're going to plug in everything that we know. So opposite is 9.3, adjacent is 7.5. In order to get theta by itself, we need to do inverse, right? Inverse of tangent. We'll use our inverse tangent like that. And then we're also going to do inverse tangent here. Okay, and what that does is that cancels out, and theta equals inverse tangent 9.3 over 7.5. Now we can get that inverse tangent by clicking second and then tangent, plugging that in, and we get theta equals 51.1 degrees. That is to the nearest tenth of a degree. Okay. Go ahead and try student example number 3 on your own.